Ladies and gentlemen, please welcome Microsoft's Corporate Vice President, Worldwide Partner Group, John Roskill.
All right, good morning, WPC 2013. What did you guys think about Alex Boyer? Woo! Unbelievable up-and-coming musician. And Alex is going to be over at 1 to 2 o'clock in the Microsoft store over in the convention center. He'll be over there selling CDs. He'll be signing autographs. If you guys want a chance to get over and meet Alex, meet an up-and-coming musician, take advantage of that opportunity. So I want to start today. We got an unbelievable day in store for you here on day 3. I want to start the day, though, by saying thanks to you all for your patience in waiting in line for the Surface. The Surface demand has even blown us away. We've gone through over 16,000 units over the last 2 days. And I know we got the line down, it's under half an hour now. And I was very happy to find out that the MPN sleeves arrived on Monday. They did clear customs. And so many of you have been picking those up. And so, again, it's a pretty cool memento and our way of saying thanks back to you for the partnership that you've shown us. So, let's get going with day 3. Usually on day 3, we start off with a segment that we called Next. And in it, what we've done in the past is we've used it as a segment to show you some of the future technologies that are being worked on, typically by Microsoft Research, sometimes involving partners, kind of give you a view out into the future, 2, 3, 5 years from now. What might we be working with? What sort of technology might be out there? Today, we're going to take a slightly different approach, and we're going to try and give you some insight to the people that are behind the technology at Microsoft. We have thousands of people, literally, in Microsoft Research working on products all across the company. And so we want to give you some insight into some of those people. And so we're going to do this in a format that follows the TED Talk format. And I've invited 3 of them here to join me this morning at WPC. So let's get this segment kicked off. And I want to introduce to you a woman named Lily Chang. Lily is an 18-year veteran of Microsoft, and she has a very impressive background in creative area, creative design. So here's Lily.
Thank you. So I'm going to start by telling you a little secret about myself. I actually began with a completely different career. I had a whole other career before computer science. I used to be an architect, and I built high-rise buildings and large-scale urban projects in Tokyo, where I was born, and also in Los Angeles. So it's actually great to be in Houston, because when I was in LA, some of the buildings that we built actually are in downtown Houston, so I've been checking them out. And I'm telling you this because, for me, architecture was sort of my entry into computer science, and at the heart of the computer, for me, it's really about the creative experience. So about 10 years ago, at Microsoft, we had this idea, which was to really rethink the operating system. What if Windows, or any operating system, your phone, began not just with your information, but with all the information that you get inspired by that other people are creating? How could you organize that? How could you see it? And how could people really come to the forefront? And that work really inspired the Windows team, so I really had the privilege during Windows Vista to actually pick up my research team and move to Windows Vista. And during Windows Vista, I ran the whole user experience team for that product. And so I think I have had a really fortunate career in being able to move back and forth between research and product and kind of go back and forth, and I've done that several times. So the work that I'm going to show you today kind of brings those 2 projects together. The heart, for me, of design and creativity on the PC, and this whole operating system idea that it really begins with work that's inspired by other people and people around you. So let me show you some demos. So one of the things that we built is a social network. It's called Social. And the thing that we've looked at in social networks is what kind of information do people love to share, really about topics of interest that they're most passionate about. So this is a is social. You could actually go up and try it out. It's so.cl online. And these are some posts that people have made in the art category. And I'm always just so amazed at what people make by things that they're finding on the web. These really beautiful posts. I think they're awesome. And let me show you how to make one. So if I want to make a post, all I have to do is I click this little create button, and I can type a topic. So, for example, my favorite architect in the world is a guy named Toyo Ito. And so rather than like a social network that you might use where you have to go out to the web, you just type a word, and we use Bing, and we bring you all that information right at your fingertips. And then all you have to do is just click on a few pictures. You might find some movies of things. You can kind of dive in if you want to make it more. And you just click a little bit, and you create really these beautiful posts. You can shuffle those around, and then really in 10 seconds, I could title it, say, Toyo Ito is king, right, if you're an architect. I can post these out to social or Facebook or, any of my favorite social networks, and there you go. Hello. There it is. And so you can see, thank you, that hopefully we've made it really easy for people to create kind of a beautiful little postcard and share that out to their friends. And if you think of today, the tools we have, it's actually kind of hard to make something like this and create it. And that's maybe the most simple create experience that we have. Well, in social, we've actually taken this idea of create experiences and wrapping them with social networking, and I'm going to show you two others. The next experiences, one is called Blink. It's about the combination of photo and videos, and then I'm going to show you some gaming things towards the end. So one of the things that we noticed as we were building this is people love sharing. These are just awesome, right? They love sharing photos and videos, and we started noticing that there were almost these magical photos that people were sharing. They look like a photo, and then suddenly you might notice that the woman's hair is moving, or the water is kind of rippling, and it kind of catches your brain because you're so used to seeing still photos or videos as separate things. So we partnered with a team called, another team in Microsoft Research that does amazing magic with photo and videos, and let me just show you that experience. So if you have a Windows Phone or a Windows 8 PC, they have an app that you can download. It's called Blink, and we've sort of integrated the social network. So let me open a video and show you how you could make one of these kind of magic photos that's a still and video combination. So I'm going to open up this fountain. So if I play this is just, a video that I shot on a recent vacation. It's very exciting. It's a fountain with a little pigeon in it. And so I'm going to make that more interesting, maybe. So you just load that up, and I can say, I really like this water, so I'm going to animate that, maybe. And I really like that little pigeon. Where is he? So I'm going to go find him. There he is. He kind of starts here, and then I think he kind of walks over here. So now let's play that. So now you'll see that the little pigeon and the water animating. Right? And the rest of that is still. And I think that if you think of marketing or advertising or just sharing things with your friends, these are the kind of things that capture people's attention. So I was wishing that I had my camera as I was waiting, because I thought that music show that we just saw would have been an awesome link to make. And then I can just publish and share that. So without really leaving the app, so I'm going to pigeon walks. Okay, it's going to be a great post. And so that just posts out to the social network. And here you can see that we've brought the piece of social, the social network, right into the application that a person who uses Blinks is going to be most interested in seeing. So you're going to see all the other blinks that other people are creating, and one of the things that I've found is just seeing what everybody else is creating sort of ups my game a little bit and inspires me to kind of look at the world as a photographer, a videographer, and capture kind of these magical moments and share them. The other one's pretty cool too. It's a little girl jumping as the puppet's moving, but the rest of the clocks in the background are sort of solid. And you can really kind of go through and see lots of other people's things. So that's Blink. It's actually best on your phone because that's what you have when you're walking around. So I encourage you guys to check out Blink and Blink in social. So the last thing I'm going to show you guys is, switch to my slides, I think. Is a game that we've been building. This is a project called Kodu. And I think this is kind of one of the most inspiring things for me. We've created a game to teach kids programming. And just like I showed you to make the photo, we want to make it super easy for anyone to create a game. So this is a little girl. I was teaching a class in LA. She can't read yet. And there she is coding a game. How cool is that? So awesome, right? And she's very intensely interested with her little Xbox controller. And we have kids teaching kids, and I'll just walk you through a few slides, and then I'll end with a video on some future work that we're doing on Kodu. It's really easy. You don't even have to read text. It works really well across lots of languages. You design your game terrain or your background, and then you can program. And programming is as easy as the first line of code basically says, I want this thing to glow blue, or when I click my Xbox controller, make something shine, something like that. And so it's really easy to make all the kind of common games that you like. And it's been really awesome for us to work with lots of partners like the people who do Sesame Street or the Boys and Girls Club, lots of academic organizations around the world. And we're really excited because we've been partnering with the Xbox team who just announced Spark 2 weeks ago or a couple weeks ago, and I'll show you a little video of that, and you can check that stuff out. If you want to see any of this work, you can just go to our website, fuse.microsoft.com, and download it. Everything's accessible, and you can try it out and try out Project Spark, which is sort of the next version of what's coming. You can sign up for the beta, Project Spark. So shoot the video.
All right, let's have a hand for Lily. Super cool, Blink, and that Project Spark. I signed up for the beta. We had an internal beta. It came out last weekend. I have 2 girls that are 13 and 15, and I'm thinking so hard about how to get them interested in technology and programming, and that's absolutely a tool that I think is going to pull them into that world of technology. So our next speaker is another 18-year veteran of Microsoft. He's coming also from the creative side. He's worked on the design team of many of the products at Microsoft. Let me please introduce Carl Ledbetter.
Thanks, John. Hi. Yeah, my name's Carl Ledbetter. I'm the creative director of industrial design for Xbox. And I have been at Microsoft for quite a while. I've actually been in design, industrial design, for about 25 years. I've worked in a number of different companies and on a number of fantastic programs that you might recognize. But what I thought I'd do today is step back a little bit and take you on a little history about how I actually got into industrial design. I grew up in Southwest Washington, actually in the foothills of Mount St. Helens, and in a very, very small town. And growing up around an active volcano, it actually had a big impact on my life. One of the things was I was super interested in geology, of all things. Being surrounded by rocks, I used to like to make things. I used to do all kinds of things with rocks. In fact, one of the things I did as sort of an unusual hobby was I used to carve arrowheads. And so this is an actual arrowhead that I made when I was 10. And what I liked about doing it was the act of carving and creating these objects with material. And these are the actual tools I used. So it starts with a piece of obsidian, which is volcanic glass, a piece of leather, and deer antler. And you carefully carve away to make this arrowhead. And one of the things about it was this idea of using rocks and nature and geology, I naturally thought I was going to be a geologist. So I went to university, studied geology, and this whole idea of discovery and understanding the world was just fascinating to me. And the first thing that the instructor pointed out was, hey, it's already been discovered. And it was completely a dream smasher, and it made me really question what I wanted to do. So I took an engineering class. In one of my first classes, we were studying a part design. And so I raised my hand, said, hey, can we change the way that part looks? I didn't really like the way it looked. And the instructor was quick to point out, no, you can't change it. That's not what we do. If you want to do something like that, go be an industrial designer. Never heard of industrial design before. I wanted to learn more. I actually walked over to the industrial design studio at the university, and when I opened the door, it opened up a whole new world of opportunity for me about design. I saw the sketches on the wall, the models of the ideas, and all these different things that people had been making, and it was a new world. And so one of the things about design that I often think about, a lot of people perceive industrial design as just simply a way to make something pretty. And this quote from Frank Lloyd Wright, form follows function, that has been misunderstood. Form and function should be one, joined in spiritual union. I've actually taken that to heart, and I think of it more in terms of solving real-life problems. So design is being a problem solver. It's about taking and creating simple and elegant solutions. And then if you think about going back to that act of making an arrowhead, it wasn't so much about the rock, it was more about the making. And so taking great pride in the craftsmanship of design. And so if we step back and say, we've heard John and we've heard Steve talk about devices at Microsoft. You may not know this, but one of the first hardware designs that were built by Microsoft was back in 1980. And it was this soft card that people could load inside of a PC and it would enable it to run some software. And in 1983, Microsoft actually designed, there was one industrial designer in the company, designed a mouse that was included with Microsoft Word. And that was to allow people to access the graphical user interface at the time. And so it was really about problem solving. How do you get these things together? So in 1995, when I joined Microsoft to design the IntelliMouse, I was the third industrial designer. And I just love the idea of connecting people to software through input devices. And today, there's almost 50 industrial designers at Microsoft, and it's still growing. And I'm part of a team in Xbox that constitutes almost 30 people. And that includes industrial designers, color materials and finish experts, product developers, design managers. It's a wide range of people, super talented, and they're international. We have designers from North America, South America, Europe, Asia, all around the world, a fantastic group of people. And this is the team that designed Xbox One. So I'm going to take, are there Xbox people out there, Xbox owners? So now I'm going to take you through the design process of Xbox One. We had to identify our opportunities and challenges. And so the first thing we did is we said, okay, we're going to design the hardware, but we also have to think about the software. We also have to think about packaging, and more importantly is all this new content that people can get to in Xbox. How do we make it simple and accessible? These are big things. Xbox is more than just games. It does all the entertainment people want. And we also had to think about the greater Microsoft ecosystem. So the design language that we use for Xbox One, it's shared across Windows and Windows Phone. And so to customers, it's about being consistent. We stepped back and looked at the history of Microsoft and Xbox when we think about the hardware. We thought really hard about Xbox. The original Xbox in 2001, it was a statement of raw power. In 2005, when 360 came out, it was about restrained power. And then in 2010, when Kinect came out, it was really a new type of interaction. So we consciously said, hey, Xbox has a bold thing to say about itself. What are we going to do for Xbox One? And we said we wanted to make it understated. We wanted to make Xbox approachable. We wanted to make it simple and elegant, and we wanted it to be crafted and tailored. So it's all about quality. And using those principles, we started to design. First thing we do is sketch. We build ideas. We start to understand what the form can be. And then in-house, we have a model shop. We build three-dimensional models. We send the database over to the model shop, and we build these three-dimensional models. We can then take the models, put them in people's living rooms, start to see how it fits in, and more importantly, we work with the engineering team to understand how the parts go together. We think about things like cooling and venting. What is the design going to look like? How is it going to fit together? And also, how do we fit all this new types of technology into Connect? And based on that, we start to build the final shape. And so the design you see here, this is where we start applying things like gloss and matte finishes. How does the vent pattern look? How does the brand come through the front? How do we make the front look high quality, just like the high-definition televisions in people's living rooms? And so that's how we have the final design of the console. And just like I was talking about the idea of craftsmanship, going back to that arrowhead, we craft every last detail on the front bezel, on the console, and the way that brand comes through in a consistent lighting effect. On the controller, we built over 200 models. And I actually have one right here. This is an example of the model. It's a rapid prototype. It's printed out right there at Microsoft. And we found that people, when we put these in their hands, could tell the difference between 1/10 of a millimeter in size. And so we made it more comfortable. We made the new controller fit a larger range of hand sizes. And we also added new things like improved D-pad performance. And also a lot of detail went into the thumbsticks. And so I think you can see here in this image, we put a micro texture. And this micro texture allows for multiple thumb grips and access. And the new ABXY buttons use a 3-shot injection molding process that makes them feel almost jewel-like. And so when you look at the 360 controller or the Xbox One controller, from across the room you can tell the difference. And so that was a lot to talk about. I know it's a brief introduction, but this is the design process we used for Xbox. We range from an architectural, more crisp design language that people can put in their living rooms and in their AV cabinet to more sculpted and softer shapes for the controller. And that's how we designed Xbox One. We're really proud of it, and we're super excited about it, and I hope you are too. Thank you.
Thank you, Carl. Any of you guys excited to get your hands on an Xbox One? Yeah. No, I know a lot of you have, they say they have kids that play it, but I know a lot of you are sneaking it in yourselves. So, our final guest this morning is a gentleman named David Heckerman, also from Microsoft Research. 20 years he's been working on solving some of technology's deepest and thorniest problems that also are society's deepest and thorniest problems. So with that, let me go ahead and introduce David.
Thanks, John. So let me take you back to 1996. It was a simpler time, a time when you got an email, you either knew who it was from or you wanted to know who it was from. That all changed in early 1997. This is one of the first new kinds of email messages I got. My wife's name is Susan, but she never used the nickname Susie. And so I was wondering who the Susie character was. And I guess you can imagine my surprise at what I saw when I clicked on that link. Of course, I'm talking about junk mail or spam. And in January of 1997, I got about a dozen of these messages in rapid succession, and I knew things were going to get very bad very fast. Fortunately, I was at Microsoft Research. I was trained in machine learning, and I could see how machine learning could help fight spam. I sent an email to my team saying, save all your junk mail. We're going to build a machine learning classifier that distinguishes good mail from bad. We did that. It worked very well. And eventually the technology made its way into various Microsoft products like Outlook, Exchange, and Hotmail. So something very interesting happened when these filters saw a wide distribution. Let me give you an example. So our filter would see the word Viagra in an email and know very likely that that email was spam and filter it out. Well, the spammers figured this out, and they disguised the word Viagra. They took the last A out and put in an @ sign. So now the human still sees Viagra, still sees the message, but our junk mail filter doesn't see the word Viagra and misses the message. Eventually, we figured that out, made our junk mail filter see Viagra with the @ sign, and then spammers would try something else clever. This time, they would embed the word Viagra in a bitmap. Again, we, the humans, can see the message, but our filters can't. So this went back and forth for quite a while, and at some point, we said, we gotta step back here and think a little bit more strategically. And we realized there's a weak link of these spammers. They want to get money from you. So let's go after that weak link. And we started cataloging links to web pages that would take money from you, for example, with a credit card. And then when a new email message came in with one of those links, we'd know very likely it's spam and we'd filter it out. So that strategy worked very well, and as far as I know, it's still in place today. Now let me fast forward about 6 years. It turns out I also have an MD. I'm very interested in how computation can help healthcare. And I got very interested in HIV and designing a vaccine for HIV. I met my collaborator, Bruce Walker, at Harvard, and we've been working on this project ever since, so let me tell you a little bit about it. It turns out there's a striking similarity between fighting spam and fighting HIV. Just as spammers change or mutate their messages to work around our filters, just as I showed you, HIV mutates itself to avoid attack by the immune system. And Bruce Walker and I are now essentially using the same high-level strategy to go after HIV, namely to go after its weak link or weak links. So if we switch video, I'll explain that in a bit more detail. This is one of HIV's proteins. It's a molecule consisting of a string of amino acids that folds together in some 3D shape and performs some function. Unfortunately, that function is very destructive for humans. Now, when you get infected with HIV, your immune system essentially attacks at some random spot along this molecule, let's say down here. And with that attack, HIV is forced to mutate at that particular site. Now, unfortunately, HIV is very robust. So when it mutates at one of these random sites, it generally functions quite well. It's like the spammers adding that @ sign to Viagra. The message still gets through. But the hope is that there are some vulnerable sites on this molecule, let's say right here where these two loops come together. And so if the immune system attacks here and forces a mutation here, the hope is then that this molecule's function will be severely crippled. If that's the case, we can build a vaccine to teach your immune system to attack precisely at these vulnerable spots and not at any of these many random spots where attack would just waste the time and energy of the immune system. So now if we could go back to the slides. Turns out my collaborator, Bruce Walker, had identified a set of individuals that made it possible to look for these vulnerable sites. In particular, he identified people known as HIV controllers. These are people who get HIV but don't get very sick. To them, HIV is more like a common cold. That's in contrast to the many, many normal people who, when they get HIV, they get very sick. So what we were able to do is look to see where the immune systems of these HIV controllers were attacking HIV along this molecule and compare that to where the immune systems of normal people were attacking HIV along this molecule. Sure enough, we found differences, and those differences point to these vulnerable spots. Today, we've cataloged about a half dozen of these spots. Also working with a friend of mine from medical school, Reed Rubsamen. Together we've designed a delivery mechanism for this vaccine, and we're gearing up to test this combination now in South Africa. But there's still at least one important challenge that remains. Turns out there are lots and lots of different immune systems. The chances that you or I have the same immune system are very small. And if you think about it, that makes a lot of sense. If we all had the same immune systems and a virus were to come along that could kill one of us, it could kill all of us. So long ago, Mother Nature figured out that that's a bad idea and gave us these different immune systems. Now, the challenge comes from the fact that these different immune systems don't all attack HIV. They're not capable of attacking HIV at the same spots. And so what we need to do is catalog enough vulnerable sites such that all these different immune system types, or at least the vast majority of them, will be able to attack at least one of these vulnerable sites that we've cataloged. So we're doing that now. It involves the use of a lot of data and a lot of computation to identify likely candidates, which then get validated in the lab. And unfortunately, I don't have time to go into the details of this, but if you're interested, you can check it out on my webpage. So with that, I'd like to say thanks for listening. I'd also like to say thank you to Microsoft and Microsoft Research. As you heard, I've been there for 20 years, and as you've seen, they've given me the opportunity to work on many problems ranging from fighting spam to fighting HIV. I can't imagine a place with more breadth or flexibility. Thanks again.
Thank you, David. Three of the thousands of people working at Microsoft that are working on technology that will, of course, impact our products, but we think actually go much more broadly and impact lives.